You know, we trust science to get things right, but what happens when a total lie gets published? Today, we're diving into how the very systems that organize our knowledge can either spread that lie or, well, protect us from it. And it all kicks off with one of the most infamous scientific papers of all time.
So picture this. It's 1998. A study comes out in The Lancet, which is, one of the most respected medical journals on the planet. And it's an absolute bombshell. It claims there's a link between the standard MMR vaccine and autism. As you can imagine, that idea just took off, spreading like wildfire, making headlines everywhere, and sparking a ton of fear.
But yeah, that's not where the story ends. After years of digging, it turned out the paper wasn't just wrong, it was a complete and total fraud. The data was faked, the conclusion was bogus, so the journal did the only thing it could do. It officially pulled the paper, basically stamping it with a giant retracted sign for the whole world to see.
Okay, so here's the real puzzle. If the scientific community officially said, nope, this is garbage, why did it keep getting cited in other research? Why did this dangerous idea hang around for decades, still influencing people's decisions? The answer, it turns out, isn't just about one bad apple. It's about a fundamentally broken data management system.
So how does a lie like this go viral? It's not always because people are trying to deceive you. Sometimes it's because the systems we built to share information have a critical bug when it comes to containing bad data.
To really get what went wrong, we need to talk about what a retraction even is. The best way to think about it is as the immune system of science, right? It's the official process for saying, hey, this thing here, this paper, it's harmful. It's got fraudulent data or major errors, and we need to pull it out of circulation so it doesn't infect everything else.
And this is where you see this huge gap between the ideal and the reality. In theory, science is self-correcting. It's transparent. But for decades, the process was a total mess. A retraction might be a tiny footnote nobody ever saw, or a paper might just quietly vanish from a website.
The immune response was just incredibly weak.
Now, that weakness wasn't an accident. It was actually baked into the history of how we record science. The problem wasn't just that one fraudulent paper. It was the whole record-keeping system. It was missing a clear audit trail.
I mean, think about how it all evolved. For hundreds of years, it was just letters and physical journals. Then we got indexes to try to keep track of it all. The digital age was a game changer, giving us these massive databases like PubMed. But there was this huge design flaw. These systems were amazing at adding new information, but they were absolutely terrible at correcting old information. There was no standard, easy way to flag a paper as retracted. That was the missing link. So this massive failure left a huge vacuum. And into that void stepped a group of people who basically said, well, if the system won't fix itself, we'll just have to build the tool that science so obviously needs.
And that's what happened in 2010. A project called Retraction Watch launched. And their idea was just brilliant in its simplicity. Let's create one single public database that tracks every single retraction. No more hidden footnotes, no more quietly disappearing papers. They were building a central nervous system for science's immune response.
And the scale of the problem they uncovered is it's mind-boggling. The Retraction Watch database now has over 30,000 retractions in it. 30,000. This just goes to show you this wasn't some rare freak occurrence. It was a huge, ongoing problem that was basically hiding in plain sight until somebody finally decided to count.
But this database did so much more than just count. By putting all of this data in one structured place, it became this incredibly powerful tool for analysis. All of a sudden, you could see patterns. You could spot the serial offenders, the researchers pumping out dozens of fraudulent papers. You could see which journals or institutions were just failing over and over again to catch bad science. It wasn't just cleaning up old mistakes. It was exposing the entire system's blind spots. And really, what this all comes down to is that building this database, it wasn't just about making a list. It was about fundamentally rethinking what scientific integrity looks like in the digital age. It proved a really simple but profound idea. Good data is what accountability is built on. So, this whole story gives us a pretty clear roadmap for how to do this right. First off, retractions have to be visible, structured data, not some footnote. Second, the databases we use have to actively warn us when we're looking at retracted work. Third, and this is key, it all relies on standardized metadata. Think of it like a common language that lets all the different systems talk to each other about a paper's status. When you have that, you can finally spot the systemic flaws, not just chase after individual bad guys.
It all comes back to this one core idea. We love to say that science self-corrects, but that's not some kind of magic spell. It's a process, and that process is 100% dependent on the information systems we build. For science to be trustworthy, the systems behind it have to make the corrections just as loud and clear as the original claims. And if there's one thought to leave you with, it's this. It's so powerful. In our world today, integrity isn't just about an individual person's ethics. It's a feature. It's something that has to be deliberately designed into the databases that hold our collective knowledge. Because in the end, how we structure our data is how we structure our truth.